From bustling city parks to quiet forest canopies, the squirrel reigns as an undisputed master of arboreal navigation. We watch in awe as they bound across branches, scale dizzying heights, and seemingly defy gravity with every leap. This image of flawless agility is deeply ingrained in our perception of these creatures. Yet, a closer, more scientific look reveals a different story, one of frequent slips, tumbles, and outright spectacular falls. The truth is, squirrels are nature's most accident-prone acrobats, constantly misjudging their famous parkour moves. How can an animal so exquisitely adapted to life in the trees be so clumsy? The paradox lies in the intricate interplay of their unique biomechanics and behavioral quirks. While evolution has endowed them with powerful hind legs and a prehensile grip, it has also hardwired them with a high-risk approach to movement. Every fall, every miscalculated jump, offers a window into the complex biological trade-offs that govern their survival, highlighting the limits of even the most specialized adaptations in a dynamic, unpredictable environment. A squirrel's primary tool for climbing is its powerful claws, sharp and curved, designed to dig into bark and provide purchase. But these aren't suction cups. Unlike the gecko's microscopic lamellae or the frog's sticky toe pads, squirrel claws are mechanical anchors. They rely on the physical integrity of the surface for optimal grip. On smooth, wet, or decaying bark, these claws can fail to penetrate, turning a seemingly routine scramble into a sudden, uncontrolled slide. This reliance on mechanical engagement is a key biomechanical vulnerability. Watch closely as a squirrel attempts to navigate a challenging surface. The claws work best when they can dig in deeply, distributing the animal's weight. But if the angle is wrong, the surface too hard, or the material too slick, the claws simply slide. This isn't just about a lack of strength, it's a failure of the specific engagement mechanism. Their paws are not designed for adhesion, but for penetration. This fundamental difference means their grip can be compromised in situations other climbers, with different anatomical adaptations, might easily handle, leading to unexpected tumbles. Beyond their claws, a squirrel's bushy tail plays a crucial role in its aerial acrobatics, acting as a dynamic counterbalance. During a leap or a sudden shift in weight, the tail whips and twists, adjusting the squirrel's center of gravity to maintain stability. Researchers have observed its precise movements, demonstrating how it compensates for imbalances. However, even this sophisticated mechanism has its limits. A tail can only do so much to correct for a truly catastrophic misjudgment of distance or an unexpected structural failure of a branch. It's a marvel of bioengineering, but not a foolproof one. Perhaps the most visually dramatic squirrel mishaps occur during leaps. These creatures are extraordinary jumpers, capable of propelling themselves several body lengths through the air. Yet, they frequently misjudge the distance or the stability of their landing zone. This isn't always a lack of ability, but a calculated risk. A squirrel might deliberately attempt an overly ambitious jump if the reward, a hidden nut cache or an escape route, is high enough. This behavioral quirk, prioritizing potential gain over guaranteed safety, contributes significantly to their acrobatic fails. Their depth perception, while generally good for navigating their environment, is not infallible, especially in dynamic situations. Factors like varying light conditions, moving foliage, or the sheer speed of their own movement can create visual distortions. Researchers suggest that their decision-making process for jumps is incredibly fast, relying on rapid visual cues rather than meticulous assessment. This speed is crucial for evading predators, but it inherently increases the margin for error when precise distance and landing spot calculation is needed. Squirrels are creatures of urgency. Whether foraging, escaping a predator, or defending territory, speed is often paramount. This inherent impulsivity, a key behavioral trait, frequently trumps careful planning. A sudden noise, a perceived threat, or the sight of a rival can trigger an immediate, unthinking dash. In these moments, biomechanical precision takes a backseat to instinctual reaction. The squirrel may simply not take the extra fraction of a second needed to gauge the exact strength of a branch or the precise trajectory for a safe landing, leading directly to a mishap. constant activity takes its toll. A squirrel that has spent hours foraging, escaping close calls, or even engaging in prolonged territorial disputes can experience muscle fatigue. Just like human athletes, fatigued squirrel muscles are less responsive, less powerful, and more prone to tremors. A tired squirrel might fail to generate enough force for a jump, hold its grip for long enough, or make the rapid, fine adjustments needed for balance. This performance degradation, though subtle, can transform a routine movement into a clumsy fall. Proprioception is the body's sense of its own position and movement, essential for complex motor skills like climbing. Squirrels possess highly developed proprioceptors in their muscles, tendons, and joints. However, even this sophisticated system can be overwhelmed or momentarily confused. A sudden, unexpected shift in a branch, a strong gust of wind, or an awkward twist can send conflicting signals, causing a momentary loss of body awareness. In high-speed, dynamic environments, even a fraction of a second of proprioceptive failure can be enough to send a squirrel tumbling. Squirrels aren't just navigating, they're constantly processing a deluge of information, scent of predators, location of cached food, presence of rivals, changing weather. This cognitive load can sometimes interfere with precise motor control. Imagine trying to perform complex acrobatics while simultaneously solving a puzzle. Their brains are prioritizing critical survival tasks, and sometimes, the fine-tuning of a leap or a grip might suffer. This multitasking, while necessary for survival, introduces another layer of potential error into their physical performance. A critical behavioral quirk is their strong motivation driven by food. The sight or scent of a prized nut can override instinctual caution. This powerful reward system leads them to attempt increasingly risky maneuvers. They'll scale precarious bird feeders, brave slippery surfaces, or make improbable leaps if the payoff is substantial. Their innate drive to gather and cache food for leaner times often compels them to push their biomechanical limits, knowingly or unknowingly, thereby increasing the probability of a fall. From an evolutionary perspective, taking risks is often a necessary component of survival and reproduction. A squirrel that always plays it safe might miss out on vital food resources, fail to escape a predator quickly enough, or lose mating opportunities. The occasional fall, therefore, is a calculated trade-off. The species has evolved to tolerate a certain level of physical mishap, as the benefits of aggressive foraging and escape strategies generally outweigh the costs of a few tumbles. Their clumsiness is, in a way, a side effect of their success. Branches are not static, they bend, sway, and rebound. Squirrels often use this bungee effect to their advantage, leveraging the springiness of a branch to add propulsion to a jump. However, this also introduces another variable. If a branch is weaker than anticipated, or if its rebound characteristics are misjudged, it can throw the squirrel off balance or fail to provide the necessary thrust. What seems like an intuitive understanding of physics can quickly turn into a biomechanical miscalculation, leading to an unplanned descent. Beyond their internal biomechanics and behavioral quirks, external environmental factors play a significant role in squirrel falls. Rain-slick branches reduce claw friction dramatically. High winds can buffet a squirrel mid-leap or cause branches to swing unpredictably. Ice, snow, or even loose leaves can create treacherous surfaces. While squirrels adapt to these conditions, they don't eliminate the risk entirely. A perfectly executed maneuver on a sunny, calm day can become a guaranteed fall in adverse weather, highlighting the constant challenge of their arboreal existence. Do squirrels learn from their spectacular falls? Research suggests their learning capabilities are more focused on spatial memory for food caches and predator avoidance rather than complex motor skill refinement from specific past failures. They might avoid a *specific *slippery branch or a *particular *unstable feeder pole after a fall, but the general behavioral tendency towards impulsivity and risk-taking remains. Their adaptive strategy is less about perfection and more about sheer resilience and a rapid recovery from inevitable missteps, rather than meticulously avoiding future errors. When a squirrel does fall, its small size and flexible skeleton often protect it. They spread their limbs out, increasing air resistance, almost like a natural parachute, and can absorb impacts that would injure larger animals. Their thick fur also provides cushioning. Falls from significant heights are common, and while not always without consequence, their ability to right themselves mid-air and land with surprising resilience is a testament to their evolutionary preparedness for these inevitable mishaps. It's a calculated design for survival in a risky environment. Despite their frequent tumbles and miscalculations, squirrels thrive. Their high reproductive rate and remarkable adaptability to diverse environments ensure their continued success. These falls are not signs of weakness, but rather an inherent part of their acrobatic lifestyle, a consequence of living on the edge of what is physically possible. Each clumsy landing, each hilarious slip, reminds us that even nature's most skilled performers are subject to the laws of physics and the inherent unpredictability of their world. The squirrel's life is a chaotic ballet, a constant negotiation between agility and the unforeseen. Their biomechanical limitations, combined with their risk-taking behavioral quirks, paint a portrait of a creature both incredibly capable and undeniably fallible. Next time you see a squirrel execute a breathtaking leap, remember the countless unseen slips that precede such mastery. And when one tumbles, instead of just amusement, perhaps appreciate the complex science and evolutionary strategy behind their hilarious, yet essential, miscalculations.